Hey guys, Miss Davis here. You are on Unit 8, Skill 2. Pause the video to write down the essential question. How can we simplify with fractional exponents? So we're going to take a look at some rules first and use them and apply them to the problems below. So fractional exponents. So what that means is we're going to have a term with a fraction up in the exponent, and we have to know how to convert it and change its form back to something that looks like this or looks like this. Okay, so within this fraction, which is the whole exponent right now, we're going to use something called EOR, E-O-R, which you see here in this box. E stands for exponent. Okay. So the exponent in this first example is where there's an A is the exponent. That looks like a weird E. This is the exponent. O stands for over. That little division line is the over. And then R stands for root. Okay, so it's exponent over, and then the bottom number is always the root. So when we go to change this, the A on the top is the exponent that's going to become the exponent in the new expression. And then the bottom root is going to be the root where the little check mark is, that's called the root. Like think of a square root. The number that goes here is the root. And then you can also rewrite, hang on, let me back it up a little bit there. This A inside here is really the exponent of the original. This is really the root. And that's how you can tell which number goes where. You can also rewrite the middle expression as this. So again, the A is the exponent, and this is your root over there in the square root check mark. Okay, just some other vocabulary. If you see something written like this, so if I have something that has like X to the A with the B in there, some other vocabulary that you might hear and we will be using, the B or the root that we just called it may also be called the index. Okay, and the number underneath, or sorry, the term, the variable, whatever's underneath, is also called the radicand. Okay, so think about radical is the same thing as a square root, so the number or term underneath the square root is called a radicand. Okay, so we're going to just go right now first to change forms between an expression written in fraction form and then rewriting it in simplified like this. Okay, so our first example here, we've got x to the 3/5. So we've got, if we use the EOR rule, we have exponent over root. Okay, so I forgot to draw the O in there, but it's exponent over root. So I'm going to start by writing the square root symbol, and I'm going to put my x on the inside, so whatever's here goes on the inside. Now the exponent of that variable is the 3, because it's the E, and then the root is the 5, so that goes in the little check mark. Okay, let's go back the other way. So now we are doing it where we have already the radical form, and now we're going to go back to the with the exponents. So we've got the exponent, and here's the root. So the root is 7, the exponent is 8. So I'm going to start with x, and I've got EOR, so it's the exponent is 8 over the root is 7. Okay, so that's how you would rewrite it. And then one more practice here. We're going to start with the square root symbol, put the x in the middle. We've got the exponent over the root. So the exponent is 1, and the root is that 5 in there. Okay. You usually don't rewrite with an exponent of 1, so this is just the, can be written like that. Okay. All right, so the next examples here, we're going to be simplifying such that there are no fractional exponents. So the rules are here for this one is simplify such that there are no more fractional exponents, which means that they want everything with a square root that has a fraction to be turned into a square root, or whatever root it is. Okay, so whenever we have this, like an example like this where we have parentheses raised to a power, what you do is you multiply. Okay, so you're going to multiply exponents. So let's just draw a little arrow. You're going to multiply exponents. okay? So what I'm going to do is I'm going to kind of distribute this 1/2 to all terms inside. So there's actually three separate, not terms, but three separate things that I have to distribute it to. So I've got the 25, I've got the x to the 1/2, and I have the y to the 4th. So I have to distribute this and multiply it by the exponent of all three of these. So this is really 25 to the 1 power. And then I'm going to distribute it here to the 1/2, and then distribute it here to the 4th. And again, in all three instances, we are multiplying, okay? So we're multiplying. So I'm going to rewrite this as 25, and then if I have 1/2 times 1 is 1/2 to the 1/2 power. And then I've got x, and if I do 1/2 times 1/2 is to the 1/4 power. And then if I do 1/2 times 4 is y to the 2nd power. Okay, so if you have just a regular number with no variable, just type this guy right into your calculator. What that really is, if you wanted to rewrite it, if we apply the exponent over root, is really the square root of, we put the 25 inside, and we put the exponent of 1 and the root of 2. So that's really just the square root of 25 is 5. Then the next term here, we're going to use again e/or, so e over exponent over root. We're going to rewrite this one as the square root, or the root, sorry, with x on the inside, the exponent of 1 and the 4 there, and then y to the 2nd power. There's no fractional exponent, so that one can just stay as it is. So we're going to rewrite this as y squared. Taking it one step farther, just rewriting our second two terms is 5. And then usually we rewrite this guy going to the end. So we want to bring out our y squared first and rewrite that next to the 5. So 5y squared. And then anything with a root in it, we usually stick on the end there. And again, we don't have to write the 1 power, so this would be our final answer. And just so you know, the operation between all of those things is multiplication. Okay, so the next example is dealing with some multiplication of across the numerator there, and then the division means we're going to have to subtract. So step 1, we're going to want to multiply across the top, which means that we need to add exponents. Okay, so whenever you multiply, you want to add the exponents across the top. So when I add those together in your calculator or wherever you want to do this, we're going to end up with x, so the same base. So we're going to rewrite the same base on the bottom, and it's going to be 17 over 12. Okay, so that's the top, divided by x to the 1st power there on the bottom, so it's x to the 1. Now if I take this and I subtract, just throw it in your calculator. When you do that, you end up with x to the 5/12 power. Okay, and again, if we apply the e/or rule, so e/o/r, that turns into root x to the 5th, so the exponent goes up to the 5, and then the 12 in the root box. Okay, so there's your answer to example 2. Go ahead and flip onto the next page. Okay, before we start the next couple problems, I just want to go over some quick reminders that when you divide, you always subtract the exponents of common bases, so in this case x and x, y and y, and any negative exponents that you have go on the bottom. If you have any positive exponents, they stay up on the top, okay? So let's go ahead and start with number 3. So we're going to go ahead and subtract 2 minus 5 as our exponent. So we're going to subtract, and we end up with -3, right? Because 2 minus 5 is -3. So since it's negative, we're going to put it on the, so here's our big square root. We're going to put it on the bottom. So it'll be x to the positive 3rd power. I always think of it as like, where are there more of them? There were more on the bottom. So if there's more on the bottom, then that's where they stay. And then when I do the second one, y to the 7th, we're going to again subtract there, minus the 3. So it's y to the positive 4. So our positive 4 exponent is going to stay up on the top. Okay, so now the next step is to rewrite it as, we don't want any fractional, oh sorry, hang on, and then I have a 2 here. If there's no root shown at all, then there's always a 2. Okay, so if there's no root shown at all, then it's just the square root, which means that there's an invisible 2 sitting out there. Okay, so now we need to rewrite this without this big square root here, because really that means that it's raised to the power of 1/2, which is a fractional exponent. So we want to get it simplified further. And what we're going to do is we're going to change it back into the form with the fractional exponent, and then simplify from there. So I've got this whole thing here. We need the exponent over root. So we have the root of 2, but inside of here, the exponent that is on this whole fraction is all to the first power. So really this exponent of the entire fraction is 1, so exponent over the root is 2. So how we're going to rewrite this is y to the 4th over x to the 3rd, whatever we had inside, and our e over our r is going to be the 1 over 2. Okay, so it's really to the 1/2 power. Anytime it's square root, really it is to the 1/2 power. So now we have to distribute our 1/2 and multiply. So we're going to multiply both of those exponents to get y to the 2nd power over x to the 3 over 2 power. Okay, so now we still have that fractional exponent on the bottom, so I'm going to keep the top the same as y squared, but we're going to apply e over down here, so e over r, and change this to over root x on the inside, exponent of 3, root of 2. Okay, so now we're going to keep it just like that because we've simplified it as far as we can. All right, number 4. So for example 4, let's make a quick note that you want to simplify the top and the bottom so that there are no more square roots and no more distributing of exponents left to do. Because right now it's really hard to do our simplifying top and bottom if these top and bottom are not simplified themselves. So let's go ahead and do that first. So the 5 and the a to the 3rd don't need any simplifying, so I'm going to copy that down as 5a to the 3rd. And then, like I said before, if there is no root in there, we're going to plug in a 2, because it's really the square root. And so we're going to apply EOR and write it as b, exponent of 5 over root of 2. Okay, so we've simplified across the top. Then on the bottom, our 15 can stay the same. We're going to distribute and multiply 3/2 by both of those exponents. And we end up with a to the 9th power. So we get a to the 9th and then b to the 3rd. Okay, so now once we have them all simplified, see how it's easier to see that we're going to do this simplified here, the constant terms there, these here, and then the b's, so the a's and then the b's separately. Okay, so 5 over 15 is going to reduce down to 1/3. So when I write down my fraction equals, I'm going to have a 1 on top and a 3 on the bottom, because what you're really doing is dividing out of 5, divide out of 5. And then we've got a to the 3rd over a to the 9th. So we're going to again subtract those, and when we do, we get 3 minus 9 is -6. Since it's negative, it's going to stay on the bottom. There's more on the bottom too, is another way you can think about it. So a to the 6th stays on the bottom, and then if we subtract these two, 5/2 minus 3, we end up with 1/2, and actually it is -1/2. So when we get a -1/2, we put that on the bottom. So it'll be b to the -1/2, but since it's on the bottom, it is now positive. Okay, and then we want to rewrite this guy right here using EOR, so E over R, and keep just our 1 on the top there, so it's going to be 1 over 3 a to the 6th, and then in our square root, or in our root again, it's going to be b to the 1st power and our root of 2. Okay, so that is fully simplified, and let's keep moving here. Okay, example 5, here we go. We got to simplify first. So I'm going to do 5 times 1/2, so multiply. And across the top, I get x to the 5/2 over, I've got to, if I got multiplication, I need to add those together. So let me just show addition between those two things. And when we add them together, again, just throw them right in to your calculator, we get 9/2. Okay, now we have to divide, so we're going to subtract these two. And when we subtract, we end up with x to the, ends up being -2 power. So when we rewrite that, we just want to make sure that we have, this is really to the -2 power over 1, right? So we want to flip that around, write it as 1 over x to the +2 to make that negative exponent become positive. Okay, example number 6 says if this is equal to x to the a over b power, what is a plus b? So we basically have to simplify this side and figure out what the exponent over base is, and then what those two numbers are, you just add them together. Okay, so we need to start by rewriting in our, using our e-or, so e over r. So if I rewrite the numerator, it's going to be x to the e over r divided by x to the 4/3. All right, now we've got division, so we have to subtract those two. And when we do, we end up with x to the 4 positive 4/3 power. So that means that this is a and this is b if we're according to this format here. So if I'm going to do this last step down here, a plus b is equal to 4 plus 3, which is 7. Okay? All right, flip on over. We're going to just do some explaining of some steps on the next two problems. So for number 7 here, it says explain, which means we're going to have to explain each step as we simplify it to get the full credit there. Well, can't write a T. Explain each step, how this right here can be written as the equivalent, so equal radical expression of root 5 square 9. So we want to prove that these two things are indeed equal, but we just have to show it using some steps verbally written out. So 3, let's just start with the original expression to the second power. So remember what we talked about before, we're going to multiply. So we're going to multiply that times that, multiplication, and we're going to end up with 3 to the 2/5 power. Okay, and because we have an answer that was different from our original, we're going to say because. This is called power to a power when we have an exponent to another exponent. So because power to a power multiplies exponents. Okay, so just kind of stating the rule that we use to get that line of answer. Okay, then the next step we're going to use e over r, so e-or, and we're going to rewrite this as, so equals the root with the 3, and we're going to have the exponent of 2 with 5 going over in the root or in the index. So remember those terms. So I'm going to draw an arrow, and we have to explain because the exponent is the numerator, so the top of that fraction. So referring to this is the exponent is the numerator, and the index or the root is the denominator. Okay, so that was our index on the bottom, or the root is the bottom part. And then the last step here is let's just simplify because we're almost there. We've almost made it match that. But we just have to multiply 3 times 3 or do 3 squared. So we end up with 5 root, and then 3 squared is 9. And we can just say for this last line, because 3 squared is equal to 9. Check, check. So we have made this equal this by a series of mathematical steps and explanations. Okay. All right, our last example here is the same idea. So explain how negative 8 to the 4/3 can be evaluated using properties of rational exponents to result in an integer answer. So an integer is basically just a whole number or any number that can be written on the number line, so negatives or positives, but it just can't be a decimal, it can't be a fraction of any sort. So we're going to again start off with the original expression, so negative 8 to the 4/3 power is going to be rewritten using EOR, so E over R, as root negative 8. Let's use parentheses here since it's negative. It's always a good idea to use parentheses when it's negative, with the root of 3. Okay, and how do we know this? Because the exponent, again, just like we said before, is the numerator and index, or the root, is denominator. Okay? All right, now what we want to do is evaluate this right here, throw that right into your calculator. So negative 8 to the 4th power, if you do that, ends up becoming 4096. So let's rewrite everything except for, so rewrite the 3 on the outside as the same. Because, let's just rewrite, well, we know negative 8, when you raise it to the 4th power, is equal to 4096. And then if you actually type this into your calculator, so again, this was in the calculator, that's in the calculator, and if you actually evaluate that, that ends up becoming just a whole number of 16. And that's just because the cube root of 4096 is equal to 16. Because 16 times 16 times 16, so in other words, it's really because 16 to the 3rd power is equal to 4096. Okay? So our final statement here, just write a quick little final statement. Negative 8 to the 4/3 power is an integer, since it's equal or equivalent to, equivalent to 16, which is an integer. Okay, so go ahead and take a moment to pause the video or finish the video and write your summary and do your practice.